This lesson will focus on inverse function. Given a function f such that f of x equal to 2x plus 1, you can see in the diagram. Now, if you try to reverse the process, say, define a function g such that you send f of x back to x, so g will send f of x to x. So in terms of writing, we have g of f of x equal to x. This g is called the inverse function of f. Now, however, such g does not always exist. There are conditions where f of x has an inverse function. The conclusion is this. If the function is a one-to-one function with a domain x and a range y, then the inverse of f exists. And we say this function is g now with domain y and range x, with g of fx equal to x. In terms of picture, you have domain of f applied by function f to get the range of f. The inverse function of f, suppose f has an inverse, then this function g will send from the domain of g, which is the same as the range of f, to the range of g, which is the domain of f. So in other words, the domain of f is the same as the range of g, and range of f is the same as domain of g. Usually we use a symbol f power minus 1 to denote the inverse of f. Note that this is just a functional notation. F power minus 1 doesn't mean 1 over f in this case. Let's do a checking. This is about the properties of inverse function. You start with x here, apply f, then you apply f inverse, you will get back x. That's why you have the composition of f inverse with f applied to x equal to x. On the other hand, if you start with y, you apply f inverse to y, you get f inverse y. Now, then you apply f again. Reversing the process, you should get back y. F composed with f inverse y at the point y is equal to y. Summary. Whatever f inverse does, f inverse will undo what f, and f will undo what inverse does. How do you know a function has an inverse? You can look at the graph and then apply a horizontal line test. When you draw a horizontal line and you cut the curve at most one point, then the function has an inverse. For example, if you have a function with a graph like this, you draw a horizontal line, and you find that this horizontal line cut the curve at one point, then the function has an inverse. Okay, so for example, this is the graph of a function that has inverse. On the other hand, if I have a graph looks like this, Then if I draw a horizontal line, I find that it cut the curve at 2 points, or it cut the curve at no point at all. It doesn't intersect the curve at all. Then this is the graph of a function that has no inverse. Alright, so this particular curve function has no inverse, because for a function to have inverse, you can apply the horizontal line test that the graph is cut at most once by any horizontal line. Let's examine if the following function has an inverse. The first function we're going to examine is the squaring function. This squaring function f, for example, have a domain -2, -1, 0, 1, 2. And when you square the number, -2 will give you 4, -1 will give you 1, 0 will give you 0, 1 will give you, when you square, will give you 1, 2 you square, you get 4. Can we find the inverse for this function? The answer is no. Why? Can we find a reverse? If there is inverse function, it must be able to reverse back. So for example, you look at the point 1. We know that -1 goes to 1 under the function f, and also 1 square is 1. But then if you try to reverse, undo what f does, f inverse will send 1 to which number? So f inverse send 1 to -1, or f inverse send 1 to 1. We cannot decide. There's no way we can tell how to go back from. So this function has no inverse. So if a function is not 1 to 1, it has no inverse. Just like in this case. How about this one? F is a function that sends 0 to 3, 1 to 2, 2 to -3, 3 to -1. Can we find the inverse of f? In this case, we find that from the arrow diagram, this is a 1 to 1 function. So it has an inverse. And what does the inverse do? The inverse will actually send 3 back to 0. Right? Instead of 0 to 3, f will send, f inverse will send 3 back to 0. 2 will go back to 1. -3 will go back to 2. And -1 will go back to 3, as you can see from here. So this is what the f inverse function will do. And the domain of f inverse is the same as the range of f. And the range of f inverse is the same as the domain of f. So answer is, can we find the inverse of f? Yes. Next, we are trying to find the formula for the inverse function, if there is. Let's take an example. If f of x equals x plus 2, this is the procedure to find the formula for the inverse. First, let y equal to f of x. So in this case, y equal to x plus 2. Then you try to rearrange and make x the subject. This is because f will send x to y. Then f inverse will send y to x. So all you need to do is make x the subject. Then you can get a formula for x. Then you can get a formula for f inverse. So we make x the subject here. X equal to y minus 2 in this case. So the formula is f inverse y equal to y minus 2. And then finally, if you want to change the symbol, you can say f inverse x or equal to x minus 2 by changing y to x. Now how do we check that this is correct? You can always check by finding f inverse f of x and see whether you get back x or not. So we know f of x is x plus 2. And we find out that f inverse of any number x is just the x minus 2. So this will give me x plus 2 minus 2 and give you back x again. So I have f inverse f of x give you back x, and this is how you verify that the answer is correct. Let's look at another example. Suppose I know f of x equals 3 over x minus 2. Find the rule for f inverse if there is a f inverse in this case. So what you do is the first step number 1, you let y equal to 3 over x minus 2. Now step number 2 is after you write this already, you make x the subject. That means you want to find out where is x now. So you cross multiply, get y times x minus 2 equal 3. And multiply out, you get xy minus 2y equal 3. Remember, you want to find out where is x here. So xy equal to 3 plus 2y. Divide both sides by y and get x equal to 3 plus 2y over y. So I have managed to define the expression where x is a subject. So the formula for f inverse now, since you know that f inverse of y will give you back x, so I have the formula for x is equal to 3 plus 2y over y. So this will become the formula for f inverse, or the rule for f inverse y now. You just rewrite one more time, get a general rule. Say f inverse of x equal to 3 plus 2x over x. Let's look at another example. If f of x equal to 2 times x cubed minus 1, I want to find the rule for f inverse. So step number 1 is you write y equal to 2x cubed minus 1. Right? This is y equal to f of x. Step number 2, make x the subject, so that I get y plus 1 equal to 2x cubed, or y plus 1 over 2 equal to x cubed. So x equal to cube root of y plus 1 over 2. So I have managed to make x the subject. Since we know that if y equal to f of x, then f of inverse will send y back to x. The picture will be f will send x to y, so f inverse will send y to x. But I just got a formula for x now in terms of y. X equal to cube root of y plus 1 over 2. So the general formula for the F inverse is S inverse of x equal to cube root of x plus 1 over 2. Next, we will talk about the graph of f and f inverse. Given you the graph of a function f, if this function has an inverse, the graph of f inverse is obtained by reflection of the graph of f in the line y equal to x. So, for example, this is the line y equal to x, which is a straight line, and you have a graph of f given. Now, the graph of f inverse is obtained by having a reflection. So, for example, this piece of the graph after reflection will become here for this particular piece, and this piece of the graph after reflection will become here, and this piece of the graph after reflection will become here, and the red one will be the graph of the inverse function. Let's look at another case. This time we're going to find out what is the graph of inverse function now. If the graph of f is given by that. So first, let's try to figure out the graph of inverse function. So look at this piece. When you do the reflection in the line y equal to x, the reflection of this portion of the graph will be there. Then let's look at this part of the graph. The reflection in this line y equal to x will be here. Then you look at the reflection of another piece. This piece here, after the reflection, it will become something like this after the reflection in the line. So the red curve is the graph of the f inverse.